on the last video. So a1 is 90 minus x, and then a2 was x, it was given. So now this is what we know. Okay, let's go ahead and read the information, but we can see from this thing. Let's look at this triangle. Let's look at triangle. I want to use the page. Let's look at this triangle. Can you see this triangle? What type of triangle is it? It's an isosceles triangle. If it is an isosceles triangle, this one here will be 90 degrees minus x, and then what will be b there? It will also be 90 degrees minus x. And then what will be the reason? The reason will be angles opposite equal sides or equal radii. Because if we know the value of that one, it has to be the same with b, because triangle OAB is an isosceles triangle. So now if we do the same thing with the I don't know if you can see triangle AOC. I don't know if you can see that triangle. Even triangle AOC, it's also isosceles. So if it is an isosceles triangle, if A2 is x, what will be C2? C2 will also be x. And then now what will be our reason? Because this is an isosceles triangle, our reason will be angles opposite equal radii or equal sides. It does not matter. So the reason we're saying it's an isosceles triangle is simply because if you hide this part, I don't know if you can, and again, if you hide that part, I don't know if you can see that triangle, which is isosceles. Don't mind the line there in the middle. There is an isosceles triangle. So now let's go ahead and see the information that we have here. They're saying chord CA intersect radius OD at E does not matter. They're saying CD is parallel to OA. So now we check if CD is parallel to OA. Can you form Z here? Yes. Look at the direction of your parallel line. So when you draw your Z, you must draw it in the same direction. So our Z will be something like this. Even our F will draw it in the same direction. So now we check. What is your Z? You know Z, you can draw it in different direction. It either this direction or the other direction. So now remember, these two have to be parallel lines. So now if you check, if you compare what we have here, let's compare the first one with what we have there. Just take this image and these parallel lines. If you put them here, we know that these two angles are equal. So if you put that Z there, can you give me this angle? But in the figure, yes, that angle is going to be O1 is equal to, then can you give me this one? It's going to be that D. So we'll just represent the dot to show that they're equal. So O1 is equal to D, then our reason will be alternate angles. So now I want us to look at the second Z. Can you see this Z? Take it as it is and put it there. So can do you notice that this angle is going to be which one? Yes, it's going to be that one. So we'll represent with a circle. It's going to be this A2. We'll represent it with a circle. But which one is this one? Where do we find that angle? So it will be here on C1. I don't know if you can see that Z there. Z, then the two have to be equal. So now you go on, we see any information that we can find on this thing. But notice something. A2 was x. So if A2 was x, what will be C1? It will also be x. And then what will be the reason? The reason will be angle. The reason will be alternate angles because of the Z. Alternate angles. So now you ask yourself questions. How will you find any of the angle here? I don't know if you can see that theorem. Guys, you need to be cautious when you deal with Euclidean geometry. You need to be clinical. I don't know if you can see this theorem. Remember what I said? I said this one in black is equal to that one with just a shade is equals to twice that one. So this is the theorem of angle at center equal to twice angle at circumference. I don't know if you can, if you look at A, O, C, D, and then you look at O1. Are you aware we have the same theorem there? Yes, we have the same theorem. So what is O1? O1 is at center and C1 is at circumference. So what do we say? We say O1 is equal to twice C1. So that means O1 will be 2x. And then what will be the reason? Angle at center equal twice angle at circumference. So now if O1 is 2x, then what will be D? Because remember the dots, we said that O1 is equals to D. So that means D will also be 2x. So now from there, you'll see the info. If you analyze your sketch before you solve, you'll see that these things, they become doable and easy. So now let's go to the question and see like what are they asking. So the first question is give reason why C1 is equals to x. And then if you go to your sketch, check, you know why C1 is x, because we used the dots, they're the circles. So now C1 was equal to x. Why? Because of alternate angles equal, simply because CD being parallel to OA. So that's your first mark. You see, it helps to fill in the information before going to the questions, but you have to be fast when you're doing that. So now let's C2, give a reason why C2 is equal to x. So now let's look at C2. What did we say about C2? Remember we said C2 is equal to A2, and A2 is x, it was given. So C2 equal A2. Why? Remember, we have an isosceles triangle, so the reason will be angles opposite equal sides. And then that's how you get your 2 marks. So now, going to the next question, the question says, determine given reasons the size of the following angles in terms of x. Now, A1, look at that. We said it. What is this thing? We said it. We said that A1, plus A2 is equals to 90 degrees. Then what was the reason? It's angle in semicircle. So therefore A1 will be 90 degrees minus x. The reason we say 90 minus x is to remember that A2 is x. So if you transpose the x, you'll have 90 minus x. So now, coming to O1, let's look at O1. Didn't we say that O1 is 2x? You see, it helps to fill in the information. So O1 is equal to 2x. Then what was the reason? Because we have that center theorem, angle at center is twice angle at circumference. So that's why we said that O1 is equal to 2x. So the reason will be angle at center equal twice angle at circumference. So now let's look at C2. Okay, not C2, O2. So because they wanted O1 and then O2. There are so many approaches to solve O1. I want you to look at this triangle. I will just highlight it. I want you to look at this triangle. Can you see that triangle? Look at that angle there. Can you see that this angle is equal to that angle plus that angle? The reason it's exterior angle of a triangle. So now if O2 is equal to A2 plus C2, and remember that A2 and C2 both of them they're equal to x. So now what will be the size of O2 in terms of x? So the size of O2 will be 2x. And then what will be the reason? The reason will be exterior angle of a triangle ABC. This is just ABC. So now let's go to the next question, because remember guys, we'll be solving so many questions this week, so that I know the grade 12s soon they'll be busy with that trial examination. I want to make sure that I cover so many questions so that they can go through these videos and learn more. So now the last question is, for which values of x will ABOE be a cyclic quad? So now let's go to ABOE and see what we have. So if you look at AB, okay, I'm sorry, this is A. Okay, let me highlight ABOE. So they want the values of x for which that figure will be a cyclic quad. So now, what do we know about cyclic quad? Even if we don't know, we don't understand the question, this is what we can do. What you know about the cyclic quad is that these are the things that comes to your mind when you think of a cyclic quad. So now let's look at these three figures and tell me if you can see those figures there. So let's start with this one. Can you see this one? The butterfly? No. Look at the points A, B, C, D, A, B, O, E. We don't have the butterfly. So that means we're not going to use this one. Now, can you see this one? Let's go and see the exterior angle. Yes, we can see it. Here is our exterior angle. But now the problem is, do you have that exterior angle? No, you don't have it. But can you find it? Yes, you can. You see, so that one is it's a bit long, because you can find this angle using which theorem? Exterior angle of a triangle. I don't know if you can see that this angle, it's exterior angle of a triangle. So this angle, we can call it CEO. Nice name. CEO is equal to, just check, this is exterior angle is equal to the sum of opposite interior angles. So that is 2x plus x. So that CEO will be 3x. So now what we know about this thing is that the exterior equal the interior. So CEO, which is 3x, which is this angle, has to be equal to that one that is inside there. So that means 2x, 3x in fact, has to be, for this thing to be a cyclic quad, 3x has to be 90 degrees minus x. So now, if you solve for x here, if you transpose x to the other side, you will have 4x equal 90 degrees. And then to solve for x, you will divide both sides by 4. So now let's check what is the value of x if you divide 90 by 4. So the value of x will be 22.5 degrees. So now, if the value of x is 22.5 degrees, the figure will be a cyclic quad. There are so many approaches that we can use. Or what you can do is, you can take the opposite angles, which is that angle. So that will be x plus 90 degrees minus x, which is this whole angle. And then we'll say plus which angle? This one. We know O2, the value of O2, we know that it's 2x. There is your O2 is 2x, so we know that the value here is 2x. So now the opposite one here, it will be 4x. So that means plus 4x must be 180 degrees. So now if we check x minus x, they are gone. Then if you take 90 to the other side, so you still have 4x equal 90 degrees. So your x will be 22.5. So that was just the approach behind that question.